And we are now going to find the sum and difference of similar rational algebraic expressions. So this is different from the similar rational algebraic expression. So later we're going to know what makes it different. Sum and difference of similar rational algebraic expressions. So at the end of this lesson, students should find the sum and difference of similar rational algebraic expression. So that is our objective for today. So the process in adding or subtracting similar rational algebraic expression is very easy because we're just going to add or subtract the numerators and write the answer in the numerator of the result over the common denominator. So you always have to look at the denominators. If they are the same, those two rational algebraic expressions are similar, and then you're just going to copy the denominator. So in symbols, that is a over b plus c over b. So as you can see, the denominators are both b, which are the same. What we are going to do is that we are just going to add the numerators. That is a plus c over b. B is just copied, wherein b should not be equal to 0. So for you to visualize the process, let's have this first example. We are going to add x squared minus 2x minus 7 all over x squared minus 9 plus 3x plus 1 all over x squared minus 9. So as you can see, the denominators here are the same. So they are both x squared minus 9. So these two fractions or rational algebraic expressions are similar. Okay, so here is the solution. So x squared minus 2x minus 7 all over x squared minus 9 plus 3x plus 1 all over x squared minus 9. So the rule says we're going to add the numerators and copy the common denominator. So here, this is the first numerator, this is the second numerator. Just add the two numerators and then the denominator, which is x squared minus 9, is just copied. This one. Okay, remove the parentheses by combining like terms. So we have x squared plus minus 2x minus 7 plus 3x plus 1. So there is no other x squared. Then negative 2x and 3x are common. So that will result to x. The negative 7 and 1, that will result to negative 6. So the sum of the numerator is x squared plus x minus 6 all over. The denominator is x squared minus 9. Third step, factor out the numerator and the denominator if possible. So if you're going to factor this out, this is equal to x minus 3 times the quantity of x plus 2. X squared minus 9, this is the difference of two squares. That is similar to x minus 3 times the quantity of x plus 3. Then, we can cancel out x minus 3 because these are the same. So, divide this one, that will result to 1. Therefore, the answer is x plus 2 all over x plus 3. So we have here the answer x plus 2 all over x plus 3. Okay, so let's have example number 2. What is the sum of 2a plus 6b all over a plus 3b and 4a plus 12b all over a plus 3b? So as you can see, these two rational algebraic expressions are similar. So let's have the solution. 2a plus 6b all over a plus 3b plus 4a plus 12b all over a plus 3b. The first step that we're going to do, again, let's just add the numerators and then just copy the denominator. So we have here the first numerator and this one is the second numerator. Then we have here copied denominator. Then just combine the terms that are alike. So we have here 2a plus 4a, that is 6a, and then 6b plus 12b, that is 18b, all over a plus 3b. So you may factor out the numerator and the denominator if possible. So the factored form of this one is 6 times the quantity of a plus 3b using the greatest common monomial factor, all over a plus 3b. So, canceling this one and then the denominator, we have the remaining value, which is 6. Therefore, the answer here is 6. Example problem number 3. We are going to subtract Negative 10 minus 6x minus 5x squared all over 3x squared plus x minus 2 from x squared plus 5x minus 20 all over 3x squared plus x minus 2. So take note of the word from. So it will give you a different solution or a different structure in solving this problem. Okay, so from the word from, we're going to write first the last given, that is x squared plus 5x minus 20 all over 3x squared plus x minus 2 minus negative 10 minus 6x minus 5x squared all over 3x squared plus x minus 2. Again, we're going to subtract the numerators and copy the denominator. The numerator here is x squared plus 5x minus 20. But since this one is subtraction, the signs of the subtrahend will change. So from negative, this will become positive. Negative, this will become positive. Negative, this will become positive. So we have here x squared plus 5x minus 20 plus 10 plus 6x plus 5x squared all over 3x squared plus x minus 2. Combine terms that are common. So we have here 6x squared plus 5x, that is equal to 6x squared plus 5x plus 6x, that is 11x, then negative 20 plus 10, that is negative 10. All over 3x squared plus x minus 2. So we can factor out the numerator and the denominator. So the factored form of this one, this is factoring trinomial wherein the leading coefficient is not equal to 1. So the factored form of this one is the quantity of 3x plus 2 times the quantity of 2x plus 5 all over 3x squared plus x minus 2. Wherein the factored form of this one is the quantity of 3x plus 2 times the quantity of x plus 1. So we can cancel this out because these are the same. Dividing a number by itself is equal to 1. So the value or the remaining value is 2x plus 5 all over x plus 1. So the answer here is 2x plus 5 all over x plus 1. So as you can see, the process here is very easy. All we have to do is just perform the operation in the numerator, and then we're just going to copy the denominator. So if we can factor out, then we can factor out. Then if we can cancel terms, then we can cancel terms. So thank you very much for listening. I hope that you learned something for today.